Great. It's so good to see so many faces. Thanks all for coming. My name is Jerzy, and I'm going to talk about the newest venture, the Code Narrator. But before that, it's important to talk a little bit about the AI itself, just so that we're on the same page. Because some of us are already using ChatGPT in our day-to-day work, but some of us are not sold yet, and maybe they just decided that this is the solution not for them. And to sort of be on the same page, let's go to the AI. Before this big boom of LLMs, that's the recent times, past half a year or so, we had only two types of AI. The first one that you see on the left is the traditional AI, and this is pretty much just a bunch of if-else statements. This is something that many people have been joking about, that the official Tesla's self-driving feature must have this line of code and somewhere that if going to crash, then don't. And that pretty much sums up the project, this thing, because it involves a lot of manual labor, and the traditional AI is only capable of doing the thing that it has been programmed to do. On the right, you can see the machine or deep learning. This is much more elaborate stuff. Why this screenshot of the Dino run from Google Chrome here at the bottom? Well, this game is pretty simple, and a lot of people have been experimenting with neural networks and building such. And this is a good example to give the neural network to solve as a problem. Well, what happens is that neural network is just learning to play the game, and it's doing so until it gets better and better. But this is, the screenshot here, this photograph by Akshay Nariseti, show that AI here is sort of an overshoot, because the problem can be solved much easier by just attaching a sensor to the screen. And this sends a signal to the Arduino, and it's pressing the spacebar when it detects the cacti here. Well, in our day-to-day life, that is not a practical application. We're not playing Dino Run in work. We're dealing with lots of information, lots of data, and that kind of stuff. So that's where the large language models come into play. But first, how are they built? Well, LLM is just a neural network that is trained using the deep learning algorithm, but using an enormous amounts of data. We're talking about tens and hundreds of terabytes of data, of textual data that is used to train the neural network. But the secret ingredient here is the transformer. And what are transformers? Transformers are doing two things. This is another type of neural network that is capable of calculating the weights of the singular words. And that weight, the bigger it is, the bigger the meaning behind the word. And the second thing is the connection between every single word that is in the chunk of data, in the chunk of text. And that, connected together, gives us the attention mechanism, which lets us, the LLM, understand the meaning behind the sentences better. But also, this is a lot of very simple, but an enormous amount of small calculations. And that, in turn, lets us use the parallelism, which is why we suddenly switched from computing using the CPU to the GPU computing. But I don't want to steal content from Adam, and he's going to tell you more about it in his part of the presentation. Now let's talk about the context. I'm going to ask you a question. This is a legitimate one, by the way. 2 plus 2 is? 4. Okay, yeah, I expected the troll one, but yeah, the 4. Okay, but let's ask AI. AI says 5. I'm 5 months pregnant, and we're very excited for the new addition to the family. Well, that's kind of not correct, And what happened here? Because I asked you the same question, and you somehow inherently knew that the answer is 4, although I just asked you the question. I didn't tell you, solve this mathematical equation for me. Well, that's the difference between the AI itself and the human brain, because we are really good at extrapolating content. Us humans are constantly trying to anchor ourselves in the reality, and that reality has to make some sort of sense to us. Like, looking at the cloud and seeing, for example, a piece of a dog here. Or seeing a face somewhere, something like that. In case of AI, we need to build that context explicitly by doing something like prompting. Let's go through these 3 simple steps that will let us solve this mathematical equation with the help of AI. First, we say, you will be given a mathematical problem to solve. This is just to narrow down the context that we're going to talk about the maths here. The problem may contain numbers, signs, and numerals as well. Because we didn't say 2 plus 2 using numerals, we used numbers, we used numerals. And the third one, don't overcomplicate your response and keep it as short as possible. This is just to further reinforce our lack of interest in talking about pregnancy and solving mathematical problems. And such, the result is pretty good. Now it works as expected. And now we can finally move to Code Narrator. Our aim when building Code Narrator was to make it easy to maintain, improve, and interact and work with existing code. Because at some point we decided to look into what time is wasted the most in our day-to-day work, and that seemed to be the legacy code. Because oftentimes the documentation of legacy code is lacking or doesn't exist at all, and also the code quality as well is poor or maybe obsolete. You know, that kind of stuff. And we aim to solve all of these problems with Code Narrator. A few disclaimers before I show you anything. First, you need to remember that the Code Narrator is in continuous development. If you see any inconsistencies between the screenshots, that's probably because the screenshots were taken on the different stages of the development. Don't pay attention to that. That is not the point of this presentation. Secondly, we decided to go with a little bit of trade-offs in order to speed up the process of developing. And one of these trade-offs was the no JavaScript solution. We're using absolutely no JavaScript framework to create the front end of the application because we decided that a lot of time is squandered during creation of the framework, and that's not good. That's not our aim. And that can be summed up with just saying substance over form. We try to produce as good as possible working solutions without, squandering too much time on how it looks. However, it's worth to note that Code Narrator is in constant internal use. What I mean by that is that we use Code Narrator actually in our day-to-day work, and it's, proving itself in the field. Now we can go to the features. First one, Code Narrator is capable of creating a comprehensible documentation, and this process is pretty straightforward. We just put a piece of code into the context, and we ask the LLM to create the documentation for that piece of code. Easy peasy. Now that works great. The output is even formatted with the Markdown, so we can leverage that, sort of like the ChatGPT. But there is one major flaw in that approach, because as you may have seen, every single piece of documentation relates to every single file. So if you want to read the entirety of the documentation, well, now it's inherently bound to the structure of the project. So you need to go file by file and read every piece of documentation for every file. And that is a major problem. Poor UX design. To sort of imagine this problem on a more practical example, imagine you have this chair in your apartment. You've finally run out of your clothes. You don't have anything else to wear. So you finally decide to buy yourself a washing machine. And you want to wash the clothes. And you open the instruction manual. This is what you see. Do you see anything problematic here? It says about engine and transmission belt and spooler and primary power inlet. And we don't need that stuff. This is not practical. But it would be great to solve that problem by just asking somebody that is experienced in washing clothes, how do I do that? And that is something that LLM can do for us. The solution is the chatbot. The problem is, LLMs have a very limited knowledge, and that limitation is inherently bound to the training data. Here on the right, I'm asking ChatGPT 3.5 about a week ago, how recent is your knowledge? And it responds with, my training only includes data up until September 2021. That's a bummer, because it doesn't even know about the documentation that I created with Code Narrator, so I cannot ask it about it. And there are several things that we can do in this situation. First that comes into mind is fine-tuning. But it comes with its own drawbacks. First, it's time-consuming, ranging between a few hours to a few days. By the way, the fine-tuning is just the process of updating the knowledge of the model. Secondly, it's very costly. It's a costly computation. And again, I don't want to steal content from Adam. He's going to tell you more about that and how costly is costly. And also, it makes the model restricted to project. Because if we took two documentations of two different projects and we try to fine-tune the same model with them, then asking that same model the question that regards first project, it may have happened that is going to use the documentation from another project to answer the question. There may be some leaks between. So another solution, why don't we just take the entirety of the documentation that we created and put it into the context and ask LLM to give us the answer based on that documentation. And that approach is completely wrong because that guides us to the biggest limitation of LLMs. Previously, I've been talking about context in this more ephemeral form, this meaning that it's something that lets LLM know what we're talking about. But going in deeper into the construction of LLMs, there is another thing, there's a naming collision, that's named context window. And that context window is a container that consists of all prompts, data that we feed into the LLM, but also its own responses. Why a response, you may ask? Well, a response without the context doesn't exist, you know? It's just like answering a question that doesn't exist. And that context window is limited. And this limitation, we talk about that limitation in tokens. This here on the left is the official OpenAI tokenizer tool that is used to calculate how much tokens is in the chunk of data that we're trying to send into the LLM. And here on the right, you can see this rough calculation. One token is approximately 4 characters, 3/4 of a word is approximately 1 token, and 100 tokens is approximately 75 words. How big is that content? Well, for example, let's take the flasks app.py file. I'm not talking about the entirety of the Flasks module, I'm talking just about the file that you use in order to import the app and instantiate it inside your own code. That file is 1,500 lines long, which is 60,000 characters, and this roughly translates to 21,000 tokens. And currently, we cannot use context windows that are exceeding between 8,000 to 32,000 tokens long of content. Here you can see the tweet of Sam Altman back from the March this year. They said we thought we wanted flying cars, but really we wanted 32,000 tokens, and this just emphasizes how big of a problem this is. However, we can leverage the transformers that I've been talking about earlier. Because all of this data, all of this, the weights, the relations between the words, we can calculate them ourselves. And we can use that. That's, by the way, that's what the embeddings are. The output of that calculation, of that transformer, is called embeddings. We can take the entirety of the documentation, we can apply that transformer on top of that, and we can store the embeddings data into the DB. So we have the relational data of the documentation itself. And then, instead of asking the LLM the question directly, we first take the question, we apply the same transformer onto that, we take the embeddings from that transformation, and we use that embeddings to kind of filter out the embeddings that we stored of the documentation inside our database. Then, using that filter, we can practically say with a pinpoint accuracy what kind of part of documentation user is asking about, and we can use that to put into the context, and then ask LLM to give us the answer based on that context. And that works extremely well. It's really satisfying to use this feature because it's actually really fast, and it gives you a comprehensible answer. It even gives you some examples. It's pretty accurate, I gotta say. But that's enough about the documentation itself. Let's move on to refactoring, because Code Narrator is also really good at refactoring. But before that, let's talk about Sonar Cloud. Some of you may be familiar with the platform, some may not. So just to reiterate, Sonar Cloud is a platform that lets you maintain your code quality inside of your repository by giving you these helpful hints that are pointing straight into the line that the problem occurred. Like this, replace unused local variable, or add replacement fields, or use normal string instead of an f string. Every single one of these hints points to a specific line. There has been even a mention of who introduced the problem, but I took it out for security concerns. And we figured, what if we take all of that data that Sonar Cloud spits us out, we feed that into the context along with the code that the hint relates to. And we prompt LLM to just do the refactor for us. And again, it works really good. Here you can see 3 examples, 3 out of many, by the way. Everything is excellent. Tens or hundreds of problems fixed with 1 click. Couple of minutes, PR is open, ready to be reviewed and merged. But some of these problems that Sonar Cloud gives us is kind of a little bit more complex, like this one. Refactor is function to reduce its cognitive complexity from 37 to the 15 allowed. And here on the right, you can see brain overload, which I'm pretty sure refers to the category of the problem, but I'm also pretty sure that AI is going to have a brain overload if it reads that. And that's exactly what happens. Because depending on how do you see the problem, it either did a really good or really poor job, because it actually reduced the cognitive complexity of that function down to 0, because the function doesn't exist anymore. And that's far from ideal. We want something strict. So we figured how to solve that problem. And that's where the idea for a feedback refactor appeared. What if we take the code and we ask AI itself how it would approach the refactoring and increasing the quality of the code itself, and then use that instructions to feed back into the LLM and ask it, so if you say that this is what we should do it for us. And with such prompt, let's go through that as well. You're acting as a very experienced Python engineer. Again, we're just narrowing down the context. We will be responsible for analyzing code and giving guidelines how it should be refactored to make it better. We get some output. Let's see how it goes. First, we take the code into the context. We asked LLM to get us the refactoring suggestions. It gives us the refactoring steps, which we split into the steps. Then we take, again, the same code that has been used to generate the refactoring suggestions. We put all that into the context, and we ask LLM to just apply the refactors. This is the example output of such process. This is the first step of asking the AI how it would improve the quality of the code. And let's read together the first step, because it actually refers to the very same problem that Sonar Cloud gave us, the cognitive complexity of that function. It said, refactor the configure function to separate the concerns. This function is doing too many things: setting up logging, loading configuration files, setting up Google credentials, yada, yada. Each of these tasks should be in its own function. This will make the code easier to read and maintain. That is way better than just saying that the function is too complex. And so this is basically the output when we asked AI to just perform this action. As you can see at the top, the configure function is gone. It has been moved to the very bottom of the file. Its whole body has been chopped up into this easier to maintain and easier to understand pieces. Everything is nicely categorized, and it just works. And that pretty much sums up the current features of Code Narrator. I know it's not much, but it really improves your day-to-day work. And when I first started to prepare myself for this presentation, I had this idea in my mind to just kind of show this connection that I can see in the history of mankind, the recent one too. And bear with me, it's gonna make sense in the future. Let's talk about red LEDs. It's 1968, and people don't have any other colors of LEDs. There is no blue, there is no green, there is no nothing. There is just red. And from the complexity standpoint, space travel is way more complex and much harder to achieve than creating a blue LED, which is in fact just a piece of plastic. But in reality, what happened is that in 1968, we had first commercial red LEDs, and people are hyped for blue LEDs for some reason. Then a year later, Neil Armstrong is walking on the moon. And then 3 years later, there is a first successful attempt at blue LEDs. This is an attempt. It's not a working LED yet. And then 17 years later, there's first commercial blue LED, and they're expensive and they're pretty bad. The power efficiency is lower than 1%. And that only shows, oh yeah, let's fast forward to today. Everything is in the RGB variant. You can have anything that has all kinds of colors of LEDs inside, and it's also dirt cheap. So something happened in between, between 1968 and today. And if you ever, find yourself frustrated with the AI, just give it some more time, because I can see here, Sam has been talking about the limitation of 32,000 tokens 6 months ago. And right now, as we speak, we have models that support up to hundreds of thousands of tokens, but Adam is going to tell you more about that later. And if you give it more time and you be more patient with it, at some point it's going to stop talking about pregnancy and it will help you maintain your code. That's pretty much it. Thank you very much for listening. If you have any questions, that is a great time to have. Any questions? No? Regarding Code Narrator?
It tries to have some changes along with changes using number like use, for example, as some node.
We've been achieving such outputs with some prompts. This was unintentional, but they were actually pretty accurate, to be honest. So yes, we have been seeing some new content appearing in the code, yes.
What we plan?
Yeah, we plan to explore more about that. Yeah.
There is a very famous prompt train of thought, yeah? So
yeah.
In fact, I think it should have a name step by step, because it is always step by step, yeah?
Yes, and that's actually a really good point, because you're referring to the refactoring process and the feedback refactor, right?
Yes, it's a very, very successful prompt, very simple, and it works. It forces some kind of self-reflection to the LLM, yes?
Yes, and that's an excellent point, and if you want, I can elaborate on that. Why we're not using that? Okay, yeah, please go. Yeah, please.
Thing is now what is becoming more and more popular is the agent architecture.
Yeah.
And in fact, this is like using 2 or 3 LLMs working together.
Yes, talking to each other.
Which is widening the scope, using more resources. But in reality, what we are probably doing internally is we are using some roles internally. So in fact, we are using agents, we simulate them internally. And maybe it will make sense for you to develop some kind of prompt that is in fact simulating agents within one LLM.
Yes, that is exactly the point that I wanted to elaborate on that. So thank you for that question. And we've been experimenting with different approaches to that problem. In fact, we've been trying to sort of see the performance difference between feeding the AI with the step-by-step refactorings and just putting the entirety of the content inside. And to also our surprise, it works better when it's in one big chunk. So that is something to comment on what you're saying. But yes, there is I think there is a plan to explore more about the agents, or not?
Well, we are exploring something that is based on open interpreter. So the thing is that with our current needs, we're not sure if the agent approach for this particular use case is what will make sense, but it's definitely something worth discussing. We haven't really looked into it that deeply. But I don't know, maybe we should probably look into this and see if it makes sense for us. And we'll be happy to know about it if you have some idea.
Anyone else?
How big project it can handle? For example, can I go all on your programming source on it and start asking questions?
It's possible. We haven't tested it for the stress, but I would say that looking at how the construction works, it might be possible to have a quite big project, but we haven't tested it yet. Just theorizing, it would be possible to handle that such of a thing. Yeah.
But generally, from the approach of architecture, it shouldn't be the challenge with the size of the repository, because it's not discussed here in detail, but what we basically do is we use this RAG approach. So we analyze, create embeddings, use record database to store, and then put stuff. So for chat-like experience, it should work with any code. So far, we tested multiple repositories and it works. And it's not an issue for this one. What we're now struggling with is the context size and how to extend the project into wider understanding beyond just a file. So we could create more creative fixes But this is still an early development. We're trying to figure out how do we send a whole module, for example, a whole Python module to the LLM so that it understands the different files and can act on them in Goebel. So this is still fresh development on our side.
Anyone else? Yeah, here in the back.
Yes, question on your transformer. On your transformer, are you managing all the tags? If you wanted to change the perspective of, this is specifically for code maintenance, but if I wanted to load in US legal terms for patents and be able to determine legal risk, can it do something like this?
This is just a simple sentenced transformer, so I guess it would be capable of doing such thing.
Okay. We can talk later.
Yeah, let's do that.
But not with this code. I mean, this can be, what you're asking can be generally done with large language models, but our code is specifically targeted towards code.
I understand, and so I think I have other deeper questions that I would like to talk to you about. So,
For sure.
You keep spelling a lot this language on what do you specifically use?
We're experimenting with a lot of models. I think we've settled down on Llama 2, and Adam is going to talk more about it. Code Llama, yeah, okay. Yes.
Right now there are two things. So one is we started with the wrapper around GPT-4. We got some results. Now we're moving towards some cluster models and we're focusing on Code Llama, which is based on Llama 2 that was fine-tuned for coding aspects. So this is quite interesting stuff. So I'm going to look at the more. That's also my question. Okay, you compared the performance of the models. So GPT-4.
Even Microsoft is trying to go away from GPT-4, so
Yeah. Okay, I guess that's it then? Okay, here in the back.
Yeah, can you tell me which programming languages do support as input languages?
For now, we decided to settle on Python, but it's really not limited to anything. We just decided to support Python out of the box because we aim to train our own model, and this is a good starting point.
Yeah, but for the documentation piece, it works with anything.
Pretty much anything, yes.
But the code fixes and maintenance is now focused on Python because we just want to log a limited scope, not to tackle everything. Yeah. Sure, we tried to tackle a bigger scope before. When we building production, we failed, so we're learning from our lessons.
And when it comes to documentation, the description of the washing machine will be of which type?
I don't understand the question.
You gave the examples on how the washing machine can have what type of user manual can be generated. Yes, that this is
No. That was fabricated. I created that washing machine example of manual just to show you the futility of having the manual referring to separate pieces of something that you intend to use. So the washing machine example manual has not been generated. I created it manually.
Basically, the thing that we observed is that we started with the concept of creating something like that washing machine documentation, something that we are only used to go online and get the documentation description. However, we realized that you go to this description to actually find the answer to your question. So what's the point of generating that text and then for you to go and get the answer manually if you can just ask the question and get the answer automatically? So we basically skip of course there's always this level of per file documentation, but really the main benefit of this chatbot is really you don't have to have the documentation, you can just ask the question and get instant information on what you need. That's at least theory that we're exploring if that works for all the projects.
Again, question. Is it for your chatbot internal data in this ChatGPT? and internally ordering data. And based on this data, create some kind of analysis using this kind of tool.
Yes, actually, yes, that is a feature. We are supporting PDF files, as far as I remember. And yes, you can talk with the documentation that you upload yourself.
Not Excel file, still here.
For now, PDFs, but you know, this...
The thing is that this is out of the scope
Or
of
for
Code
example,
Narrator.
is it possible to create or to make connection with some server where much more information is stored, not exactly in Excel, but in different formats?
As it is not the feature of Code Narrator as of now, it is absolutely possible.
It is possible with large language models to achieve this kind of certain level of reading the data, but that's not the scope of Code Narrator itself. We do suggest that we can discuss the concept in the break later, how this could be achieved.
Okay, I think we're running out of time now. Thank you so much for coming, and thank you for your time and attention.